Let L be the angular and linear momentum operator respectively for a particle. The commutator Lx Py gives. Solution. Lx Py is equals to y pz minus py z into here py. So we can express y pz py minus py z py. The value of commutator of this would be 0 as there is no term. Py, either y py should be there or z pz should be there. So we are left with this commutator only. Now we expand it using property y pz py plus y py pz. This commutator is again 0, so we are left with this one. This is I h cross pz. So our result would be this one, where we have used y py is equals to I h cross p y py equals to 0, z py equals to 0 and pz py equals to 0. An operator for a spin half particle is given by A equals to lambda sigma dot B, where B is equals to B by root 2 along x and y direction. Sigma denotes the Polish matrix and lambda is constant. The eigenvalues of A are. We have A is equals to lambda sigma dot B. Further, B is defined as B by root 2 x cap plus y cap. So vector A can be written as lambda sigma x bx plus sigma y by plus sigma z bz equals to lambda sigma x bx by root 2, b by root 2 plus sigma y b by root 2. That is, we would be having it lambda b by root 2 sigma x plus sigma y. This can be written as lambda b by root 2 0 1 minus I 1 plus I 0. Eigenvalue of sigma x plus sigma y is obtained from the circular equation. That is minus lambda dash 1 minus I 1 plus I minus lambda dash is equals to 0 implies lambda dash square is equals to minus 1 minus iota 1 plus iota equals to 0 implies lambda dash उसका minus 2 equals to 0 और lambda dash would be plus minus root 2. Thus, the eigen value of operator A is equals to lambda B by root 2 multiply plus minus root 2 equals to plus minus lambda B. So our answer is option B, plus minus lambda B. A particle is confined in a box of length L as shown below. That is, initially it would be like this one, but this area has been reduced or subtracted from the box. Now, if the potential V0 is treated as a perturbation including the first order correction, the ground state energy is. We have to determine the ground state energy for this potential. Now, the correction in the ground state energy is given by shaded area, that is this area. So E0 E11 is equals to area of shaded portion of potential divided by total width. That is, area of shaded potential would be V0 L by 2. Total width will be L. So this correction term would be V0 by 2, where we have used area of shaded portion, area of rectangular, that is V0 into L by 2, and total width equals to L. The ground state energy for this potential is E1 equals to E1 equals to E10 plus E1 of 1, which is equals to pi square h square by 2 ml square plus V0 by 2. Thus, our option D is correct. We are discussing GATE Physics 2015 previous year questions of quantum mechanics. Let us read this question. The Pauli's matrices for 3 spin 1 by 2 particles are sigma 1, sigma 2 into sigma 3 respectively. The dimension of Hilbert space required to define an operator O sigma 1 dot sigma 2 cross sigma 3 is. Solution. the dimension of Hilbert space is given by since we are having it 3 spin equals to 2s1 plus 1 2s2 plus 1 2s3 plus 1. If there would be any spin, we can multiply it here. So in general, the dimension would be related by this relation. If instead of here s1 equals to s2 equals to s3 is half, then this relation would be 2 into 1 by 2 plus 1, 2 into 1 by 2 plus 1 and 2 into 1 by 2 plus 1, that is equals to 2 into 2 into 2 equals to 8. Further, instead of a spin, if dimension is required from coordinates, then relation will be of Hilbert space (2d plus 1) for x coordinate, x or p coordinate, dimension of Hilbert space would be 2 1 plus 1, that is 3. So this is a general relation for dimension of Hilbert space. In this case, our answer is 8. Consider a system of 8 non-interacting identical quantum particles of spin 3 by 2 in a one-dimensional box of length L. The minimum excitation energy of the system in unit of pi square h square by 2 ml square is. Now, solution. Spin of the particle has spin 3 by 2. That means degeneracy in this state would be 2s plus 1, that is 2 into 3 by 2 plus 1, that is 4. So that means in ground state there are 4 eigenstates. For n is equals to 1, there are 4 eigenstates. N is equals to 2, we know it, there are 4 eigenstates for hydrogen atom, and that is n is equals to 3. Similarly, I would be writing it down, n is equals to 1, n is equals to 2, and n is equals to 3. There are 9 states actually. So I'm just making only 3, 3, 6. So I'm not making 9. I would be taking only like this. For 9 state, 4 state. In reality, there is 1 state, but spin is 3 by 2. So here you will be having 4 state. This is for ground state distribution. This is for excited state. Now Let us distribute each particle. Since particles are identical, that means each state can occupy only one electron. So, in ground state system, 8 particles would be distributed like this one. In excited state, the distribution of particle would be like this one. Now, the energy of particle ground state is so E0 will be 4 into 1 square pi square h square by 2 ml square plus 4 into 2 square pi square h square by 2 ml square. That means we would be having it 20 pi square h square by 2 ml square. The energy of particle in excited state is E1 is equals to 4 into 1 square pi square h square by 2 ml square plus 3 into 2 square pi square h square by 2 ml square plus 1 into 3 square pi square h square by 2 ml square, that is 25 pi square h square by 2 ml square. The excitation energy of the system is that is E excitation would be E1 minus E0, that is 25 pi square h square by 2 ml square minus 20 pi square h square 2 ml square, that is 5 pi square h square by 2 ml square. Thus our correct answer is 5. Suppose a linear harmonic oscillator of frequency omega and mass m is in a state defined by this at t is equals to 0, where psi 0 and psi 1 are the ground state and first excited state respectively. The value of psi x psi in unit of h cross by m omega at t is equals to 0 is. So we have psi is equals to 1 by root 2 psi 0 plus e की power I pi by 2 psi 1. Now the expectation value of x given by x is equals to psi x psi, which can be written as 1 by root 2 psi 0, 1 by 2 psi 0 x psi 0 plus 1 by 2 psi 0 psi 1 x psi 1 plus 1 by 2 e की power minus I pi by 2 psi 1 x psi 0 plus 1 by 2 e की power pi by 2 psi 0 x psi 1. Now we know that psi nx psi nx equals to 0 implies psi1 x psi1 equals to psi2 x psi2 is equals to 0, and the value of psi1 x psi0 is equals to psi0 x psi1 is equals to h cross by twice m omega into delta 0 to root 2 plus root 1 0 0, which is equals to h cross by twice m omega. Substituting this value, in the expression of average x, we get delta x is equals to 0 plus 0 plus 1 by 2, that is root h cross by twice m omega into e to the power minus I pi by 2 plus root h cross by twice m omega e to the power I pi by 2 into 1 by 2, which can be written as root h cross by 2 m omega cos pi by 2, which is equals to 0. So the value of average x for the given wave function is 0 and its answer is 0. Let the Hamiltonian for two spin half particle of equal masses m, moment of p1 and p2 with position on r1 r2 is defined as this, where sigma and sigma 2 denotes the Poisson matrix and h omega is 0.1 and k is 0.2 electron volt. So this system is for 3-dimension particle. One particle is in 3-dimension system. Solution: we have h is equals to p1 square by 2m plus p2 square by 2m plus half m omega square r1 square plus r2 square plus k1 sigma 1 dot sigma 2. Now sigma 1 dot sigma 2 is expressed as sigma r is equals to sigma 1 plus sigma 2 implies sigma 1 dot sigma 1 equals to sigma 1 plus sigma 2 dot sigma 1 plus sigma 2. Now, so sigma square is equals to sigma 1 square plus sigma 2 square plus 2 sigma 1 dot sigma 2 implies sigma 1 dot sigma 2 would be 1 by 2 sigma square minus sigma 1 square minus sigma 2 square. Since ground state is 4 h is equals to 0 state, that is sigma is equals to 0. Further, sigma 1 square would be 3 and sigma 2 square would be 3. How? Because sigma 1 square would be having sigma 1 x square plus sigma 1 y square plus sigma 1 z square, which is equals to 1 plus 1 plus 1 equals to 3. Similarly, sigma 2 square would be 3. The value of sigma 1 dot sigma 2 would be 1 by 2, 0 minus 3 equals to minus 3. Thus, the value corresponding to given Hamiltonian is E is equals to 2 times 3 by 2 h cross omega, where I have used ground state energy of a particle in 3 dimensions. E0, here I am defining nx, ny, nz is equals to nx plus ny plus nz plus 3 by 2 h cross omega. So E000 would be 3 by 2 h cross omega here plus and 2 into 3 by 2 h cross omega plus this term k into minus 3 equals to, now what is the value of k? K is 0.2 eV. So we would be having it 3h cross omega equals to minus 3k equals to 3h cross omega is equals to 0.1 minus 3 into 0.2, which is equals to minus 0.3 eV, where h cross omega is 0.1 and k is equals to 0.2 eV. So our answer for this problem is 0.3 eV with negative sign.